right, let's look at molecular geometry. When we get a molecular formula, we know it's molecular because we have all nonmetals. So we need to determine the structure. Okay, so if we go through these steps, it's very simple. So we have the formula. So calculate the valence electrons. Hydrogen brings 1 valence electron. We've got another hydrogen. It brings 1 valence electron. Sulfur brings not 2. Sulfur brings 8 valence electrons. No, that's not right either. Okay, let's try this again. Sulfur brings 6 valence electrons. Like that. Remember, all we have to do is count in the tall columns. So our total valence electrons are 8. I'm getting ahead of myself. Okay, so we have 8 valence electrons to work with. So determine the central atom. It's going to be the element that can make the most bonds. So sulfur is going to be in the middle. Hydrogen is going to be on the edges. So, number 3, attach remaining elements to central atom using single bonds. Count bonded electrons and subtract from the total valence electrons. Well, each bond is 2, so we've used 4. We have 4 electrons left to use. So we have to satisfy the octet or the duet rule. Okay, well, hydrogen only wants 2, so it's got its duet rule satisfied. So if we give sulfur its octet, we've used all of our electrons. And so let's look at this. Hydrogen has access to 2 electrons. This hydrogen also has 2 electrons, so it has its duet rule satisfied. Sulfur, 2, 4, 6, 8 electrons. There's our octet rule. Now, since I've sort of junked that one up, let me rewrite it. Okay. So, number 6, we subtracted from the total and we're out of electrons, so we don't have to do anything else. So, count sets of electrons. 1, 2, 3, 4 sets of electrons. So we need to look at what is our electron pair geometry. Well, look here, our electron pair geometry. 2 sets gives us linear. 3 sets gives us trigonal planar. 4 sets gives us tetrahedral. 5 sets gives us trigonal bipyramidal. 6 sets gives us octahedral. And 7 sets gives us pentagonal bipyramidal. So we have 4 sets of electrons, so our electron pair geometry is tetrahedral. But we need to get the molecular geometry. because we have two bonding pairs of electrons and two non-bonding pairs. So our molecular geometry is not tetrahedral because we don't have four bonds. So if we look at our molecular geometry, we only look at our bonded atoms, and we have two bonded atoms, and those two lone pairs is what would give us that angular shape. An angular also called bent.